See, no, we discussed it. Okay.
Okay.
No, I finished. No, not possible.
You finished?
Yeah, I finished. I told everything what I know about that.
So, summarising why Boscovich has been overlooked, you think it's because of what?
First of all, in some extent he was behind of his time concerning mathematical presentation of his theory.
Yeah.
And in some extent he was far ahead of his time.
So the physics ideas were too...
Physical ideas, comprehensions was far.
At the time he was living in, talking about a physics like that would not have been something people could have comprehended so easily. They would have had resistance against that sort of idea.
No, I think not that people were not comprehending, maybe, but for them it was strange.
It's too strange an idea.
Strange idea.
So it was a strange idea for the 18th century.
Well, strange idea for 20th century.
Yeah, and do you think it's strange for the 20th century? Do you think it's a strange idea for the 21st century? Or do you think it's more acceptable now?
No, we are 21st century. And if I ask someone, see,
yeah,
is this curve present in modern science?
Yeah.
We can ask.
Yeah.
And I am sure that maybe one man will know, but nobody knows.
Mm-hmm.
This curve was made in middle of 18th century.
Yeah.
But I showed that you recorded it, that such curve exists in the 20th century. See?
Yeah. Oh, very good.
You see.
Yeah.
Is it real?
Yes.
So people doesn't know. Here, those people discover this interaction.
Yeah.
These Russian authors discover this interaction and put at the front page of his book. We discover something new.
Yeah.
They didn't know that Boscovich made the same curve 2.5 centuries before.
Yeah.
So that's he's in front, not on ahead, not of ahead of only for people in his century, 18th century, even today, because people doesn't know.
Yeah.
That's the answer. So
but the basic idea now, Tesla's theory can be more easily understood if we were to...
Boscovich's theory.
I'm getting it wrong for myself. Boscovich's theory
yes.
is more easily understood by a modern 21st century mind.
It is so simple theory,
yes.
so simple to understand that unbelievable.
Yeah.
Just to think, just to read.
Yeah.
Very simple.
Yeah.
And he explained very clearly in many details, just so people read.
So,
and there is Latin edition, there are English edition, there are in our language edition. You can, this book in English edition you can find on internet, free of charge to take. So.
Yeah, your ResearchGate, your papers are on the internet now. Yeah.
I think not only our book, my book, but also Boscovich's theory.
Yeah.
There is PDF file, complete theory on internet. And both editions in English, there are 2 editions, and both editions are on free of charge. You can take from internet.
Yeah.
So that's it.
So,
people just have to read, nothing else.
That's right. Yeah, and understand.
And to try to understand.
And try to understand. Do you think people will be able to understand it more?
What is for me, maybe this is important to record. What is important? There are not so much. There are a few people dealing with Boscovich. I know some of them. For example, I will mention the name of the physicist here in Serbia, in Yugoslavia.
Yeah.
For example, Dragoslav Stolijkovic was very known our physicist. He died, but he was known. And dealing with Boscovich, wrote the books. Then it was Ernest Stipanic, mathematician.
Yeah.
Also, he wrote a book about Boscovich. There are also Alexander Tomic, still alive.
Yeah.
Very well-known scientist, excellent, how to say, man who knows about Boscovich very well, and wrote a lot of articles about him. There is in Croatia, Ivan Supek, a very well-known physicist, wrote a book about Boscovich. There is Žarko Dadic, member of Academy of Science in Croatia, and Dadic was also. Dadic wrote a nice book about Boscovich. You have no this book, I will give you.
Are they all?
And there are to them. And what is important to say? All of them explain Boscovich's theory, influence on many other. Also, those Žarko, those Markovic, I don't know him, 2-volume book about Boscovich. But no one of them in our country and abroad have tried to see if this curve has been confirmed by modern science. No one has tried. There are people dealing several 10 years about Boscovich, and to see, okay, if it is true or not. I am the first man and the only man up to now who tried to check the validity of this curve, to see what is the modern science achievements and results. And I found a lot of examples. At 11 steps in the hierarchy of matter, about 60 examples. Even now I stopped to collect them because there are a lot of them.
Yeah.
So Boscovich's curve was confirmed. But it is strange that people, well-known scientists, people seriously dealing with Boscovich, didn't ask themselves, is the curve correct?
So why wouldn't they have asked that question then?
Sorry?
Why wouldn't they have asked that question?
Ask them.
Have you got any ideas?
This is not the question.
Yeah.
Maybe they are not engineers. I'm engineer.
Chemical engineer.
Engineer, that's more important to say.
Yeah.
Because chemical engineer, but engineer we have different kind, we have only practical side.
Yeah.
Okay, that's theory.
Yeah.
Is it valid? Can I use it?
Yeah.
That's what I think.
Yeah. So as an engineer,
But it is many other aspects. For example, look at the history of philosophy.
Yeah.
There are I have read several of these histories.
Yeah.
One is history of Hegel, and I don't know exactly now the name, but several books.
Yeah.
And all the history of philosophy, it is started from some ancient times. This philosopher told that his comprehension is this. Second one, this. Second, this one.
Yeah.
There is no attempt to criticize, to analyze opinion, to compare their opinion, to say, okay, this is okay and confirmed, and this is valid, and this is a mistake. There is no attempt to evaluate these theories, comprehension of these philosophers. No attempt. Why? When I have read a lot of books, or original books, original means translation in my language or English, but written by those philosophers. And always I'm reading, and all the time I'm thinking, is it okay or not? Is it confirmed or not? Because all the time I try to analyze and to verify it. But the others just mention this, and so on.
So maybe it's people who didn't look at that issue weren't thinking of it in terms of an engineer wanting to use it, sort of thing. That may be the difference. You looked at it and said, can I use this theory? Has it applications?
For it is valid.
Yes. And you found it was valid, and the other people may not have been looking at it in that way.
Also, I mentioned this previously, maybe we recorded it, about this attraction-repulsion story
Yeah.
concerning Friedrich Engels. Believe me, there are, I don't tell you how many articles and books there are about in this communist period.
Yeah.
Believe me, if he, in his book, every sentence is elaborated,
Yeah.
believe me, but no one word about attraction repulsion. And I will show you. And because I put in this book also.
You got the quote. Yeah.
Here. You can see. This is content of this book.
Yeah.
And it is possible to see that all possible, let me see, to see. This is forms of the motion. I will not, okay, you recorded, now I can read. See,
Okay.
by attraction repulsion, Engels tried to explain. Transfer of motion, then law of conservation energy, that interaction between two bodies, planet rotation, earth mechanics, heat, electricity and magnetism, chemical processes, changing of one form of motion to another, importance of solar energy from the processes of the earth, concept of force, origin of solar system, then general question in the electrics, magnetism, electricity, chemical processes, then repulsion in the tails of comets and gas, gravitation, condensation of the matter, thermal expansion, motion equilibrium, motion on one heavenly body, and so on. So on. And this is it. From page 17 to last page in 324 here, all pages, and written in period from 1880 here 1875 and so on. So he wrote this book, but he didn't finish this book, but he wrote in the whole period he wrote this book, he covered this. And all this is in his book.
Yeah.
Book covered about solid attraction repulsion. And nobody noticed that. Nobody noticed that. I read not only our books and articles, I also visited Russian libraries. No, Вопрос философии, that's Russian, that's philosophical issue. Вопрос философии. I looked, there are a lot of articles about this book. Nobody mentioned. Also about Hegel. There are a lot of presentations of Hegel's philosophy, a lot of them. I will be very glad if somebody show me that he analyzed, or someone analyzed, Hegel's comprehensions of attraction repulsion. No, you cannot find. Even that it is mentioned, only one, I remind myself, concerning Engels, that was Kedrov. He's a physical chemist, but also a philosopher. He mentioned that Engels, yes, this one, yeah. Engels wrote attraction repulsion, nothing else. Just mentioned one word, stop.
Yeah.
The only man. So people does not know to read. Because of that, when I want to be introduced with some comprehensions of some scientists or thinkers, philosophers, I always try to read this book he wrote. Because if I read a book of some other authors, who know, maybe a lot of things were missing.
Yeah.
Maybe a lot of things.
Yeah.
So I, for example, when I read the Kant, because attraction and pulsion, I did Engels took from idea from Hegel took idea from Kant. And there is a book of Kant, I don't know the name at the moment, well-known book, in which in this book he developed this hypothesis about origin of solar system. I read this book, original version, printed in his time in Germany in Gothic. To be sure that I read indeed original book. Although I have a translation in my language, but I read an original compared with translation, look at it, to see maybe there is mistake, error in translation. Although I know German is so bad, but in any case, I want to see what is written. Maybe something is missed in translation.
And was there? Was there something mistake?
Maybe some mistake or missing.
Was there something missing?
I didn't find there something missing, but in any case, always read original.
Yeah.
See, for example, you have translated PhD thesis of Dusan Nedeljković. You have translated it from French.
Yeah.
Yes. I had no chance, had no read this book, but it was written, this thesis was in period 1920 or 22, as I know.
Yeah.
I'm not sure if there is, it is time to compare his philosophy with current sciences in that time.
Yeah.
Are there something about that?
I don't know. I was hoping to get something about Einstein when I...
Because I read some other articles of Dusan Nedeljković,
Yeah.
published much later, but also he speaks, just Boscovich says this, Boscovich wrote this, but no critical evaluation, no verification of this concept. Just repeated what he says. And there is no progress in the time. If there is no repeated, how to say, there is no verification, if there is no analysis, evaluation of some thinking.
It's not always possible to do the experiments at the time.
See, for example, in many literatures dealing with Boscovich,
Yes.
it is written. That it is written there. Boscovich believes that elementary particles are like points,
Yeah.
without any dimension. And all of them name this point, those points are Boscovich's atom.
Yeah.
In many, Boscovich's atom. And what is the truth? Boscovich never named his points as atom. Never.
The last thing...
Because Boscovich also wrote about atoms that have dimensions, that have parts, and that are divisible. Boscovich spoke about atoms and put the name atoms, put the name molecules.
It's trouble though that with the original Greek meaning of the word atom was that it was to be a particle that was not to be
this atom is that's a question of terminology, but
yes.
If someone named the Boscovich points as atom, then he will completely ignore those parts of Boscovich comprehensions about atoms. He wrote about atoms. Those atoms are composed of his particles, of his points. He wrote this.
There's difficulty in translation because the word atom in Greek was supposed to mean something not cuttable, and then Dalton used the atom to be.
I know that.
It changed its sort of meaning.
Yes, it is.
Yeah.
I know that.
Yeah.
But if you are correcting, presenting Boscovich theory, he said, Boscovich, this is point. Boscovich speaks about atom also.
Yeah.
I will be very happy if you or someone find that Boscovich tells something about atoms.
Yeah.
Nobody missed that. Nobody mentioned it. And see, in one, so this is a question of writer, but also how the scientists think. See, for example, a Greek scientist, not scientists, philosophers,
Greek philosophers, ancient Greek.
Ancient Greek, came to the idea about atoms, and atoms are not be divided and so on.
Democritus.
Democritus, Leucippus, and 2000 years later, First Boscovich, there are the other people speaking about atoms, but I will tell Boscovich mentioned atoms as divisible particles composed of those points, his points. That was in 1758, middle of the 18th century. 50 years later, John Dalton, English physicist and chemist, concluded that there exist smallest particle of chemical elements. And he believed that those smallest particles cannot be divided. And he had in his mind, he recalled to the Greek philosophers and named this smallest particle as atoms. You know that.
Yes.
But half century later, at the end of 19th century, Joseph Thomson discovered that there are electrons negatively charged, and there are some positively part of the atom. So he concluded that the atoms can be divided. Those atoms of chemical elements can be divided. There's no story. And now there is one American scientist, and in journal Scientific American, well-known popular journal, present this short story I just told to you from Greek to the atom, and concluded that Leucippus and Democritus made mistake because atoms can be divided. How stupid that man is. Because those particles, those smallest chemical particles that Dalton discovered, never will be, Leucippus, Democritus will never name this as atom. Never. And it's not mistake of Leucippus, Democritus. This is error, mistake of Dalton, because he put that name. Although I respect his contribution, it's excellent. But occasionally he put wrong name. For me, those particles of chemical elements should be called Daltons, according to his name. He deserved it. But Daltons all can be divided. But this is Daltons. But see, I speak also those people in this scientific journal, Scientific American, Greek made mistake. Atoms are divisible.
I think it's a problem of how do you start, because you can start by two different ways. You've got the word atom, and you could say, well, I'm going to define the word atom to mean a particle that is not divisible. And taking that approach, if a scientist comes along and says, oh, I've discovered this particle and I think it's an atom, and he says, well, I'm naming it an atom, and then later on somebody decides I can cut it smaller, does that then say you've misnamed that particle as an atom? Or are you going to say we're going to keep that name for that particle as an atom? It's what do you do with the word atom? It's
Yes, I know that.
It's very difficult to know what to do with that. If you name something an atom and you're using the word to mean uncuttable, and then you find you can cut that particle,
But
that means you misnamed that particle atom, or are you going to keep calling it atom and then change the meaning of the word to mean something that can be cut smaller? And it's this problem with words.
yes, of terminology, yes.
It's sort of, what do you do? Different people kind of look at things in a different way all the time. Some people will say, well, I'm going to name something an atom, and if I find out later it's not an atom, then I misnamed it, and they're going to go it that way. While other people are going to go, I'm going to call this thing an atom, and if I find that it's not an atom, I'm going to say something else is. So you just say I've misnamed it. So there's sort of like two approaches all the time, and it gets really confusing with what have people done when they're doing it like this. So when you go back to the ancient Greeks, what they were talking about, what I can understand as a particle which they called an atom, is nothing like what Dalton would have called an atom, even when he believed that what he was calling an atom was uncuttable. It's a sort of like completely different thing altogether. It's sort of like you've got the word atom, and over the centuries people were trying to put that term onto different things all the time.
Yes, but also
Yeah.
that's another close connected with this, but not exactly. Concerning the atoms and matter. Very frequently, almost in every textbook on physics and chemistry,
Yeah.
you will find statement
Yeah.
that Greek philosophers, Stolijkovic and Democritus,
Yeah.
was the very first who came to the idea that matter is composed of atoms.
Yes.
That the matter is composed of atoms.
Yeah.
So, those two Greeks
Yeah.
were very clever to
Yeah.
state such stupid sentence.
Stay-
They never said that matter is composed of atoms. Never. Never.
It's only because there's so little.
We mentioned it just
Yeah.
what they said.
Yes.
They said matter is composed of voids and fullness.
Yeah.
Those fullness, that's atoms, and the rest is void. And matter is composed of two components, atoms and voids. Voids. This
Yeah.
is second one. So, listen, this table, if I say that this table is composed of atoms, that means I have in the mind only there is carbon, hydrogen, and oxygen mainly, maybe something else, but this is mainly this.
Okay.
Is it true?
Yeah.
Carbon, oxygen, so. But do you know that in this table, 99.99999999999 is void,
Yeah.
and only 1 0.00000000000000 12 times 1
Yeah.
is those atoms I mentioned, carbon, hydrogen, and oxygen. So what is this? Void. Most of this table is void.
I find.
And this is concept of Stolijkovic Democritus.
Yeah.
They never, whenever they mentioned atom, second word it was void. Always void. Always two these terms, emptiness and fullness, or they keep together. Never mention only one of them. And Dalton also said, when two atoms, when I say that two atoms are touching each other, I mean there is only at least small void between them. Always void. No touching, not possible touching. Must be void. Not possible to if they touched physically and mathematically, there will be no void between them. No, there is void. Always. So matter is not atoms, molecules, nucleons, protons, etc. Matter is that fullness, E plus void. Second part of the matter, as much as important as this fullness.
Well, one of the things I find confusion is the use of words, and sort of like if you're saying most of that table's not there, and okay, so approximately there's no table there.
I don't tell you it's not table there.
But
I tell you what is the fraction of the void in this table.
Yeah.
And this fraction is 99 point. Then put here.
Yeah, there's more than 90%, 99%, more than 99% of what you're pointing to isn't there. So that approximately nothing there.
No, isn't that? It is there.
It is there.
It is there.
Even though there's so little.
What says Leukvidemokritis? The fullness exists, and the void exists in the same extent as fullness. The same. So they put the existence to both sides. Just not exist. Exist. And this void is not just, for example, what is void? That's atomic orbitals within atoms. Orbitals.
Yeah.
That means some space, definite shape, definite size, definite energy to need to approach it, definite capacity, what number of electrons and this is that void, orbitals. And initially, before Big Bang, the atomic orbitals didn't exist initially. They have formed as the atoms is formed. Atoms is composed of proton, neutron, electron, and void. Orbitals.
The problem that you're talking about, I've forgotten the Latin word, but you're talking about creation from nothing. And that was so a lot of people having this problem with creation from nothing. So you can't create something from nothing. Is sort of in some people's way of thinking about things.
For me, to create from nothing and also to annihilate it to nothing, I cannot accept this. It is for me.
So
I cannot accept that.
Can't accept what? Sorry.
That from nothing. That you can create something from nothing.
Yeah, but
or to disappear to nothing.
Yeah.
Something to disappear to nothing.
But I think, as far as I can understand, the Big Bang Theory and all that is it's creation from nothing.
No, there was something.
There was something there. There's always something.
No, there are quarks.
Yeah.
Some leptons, quarks. Some I don't know exactly.
So the quarks have always existed.
They exist, yes.
And by that you mean the point particles.
According
what we think is as Lederman is pointing out, he thinks that quarks are point particles. So the point particles have always existed, and so when talking about creation from nothing, it wasn't. You always had point particles.
Creation, but there is according. Big Bang theory, there was no point particles, there are quarks.
Sorry?
There are quarks, not point particles, there are quarks.
They're quarks, not point particles.
Boscovich, from Boscovich point particles. Quarks are quarks. Lederman make it is equal, but it is not equal.
So
First of all, there are different quarks and anti-quarks.
Yeah.
And there are also some leptons at the moment. For Boscovich, and there is those quarks are different between them. They're not the same. But there's 6 quarks and 6 anti-quarks. Maybe I make mistake, I think so. But what is it? But there are different types of the quarks. And that's.
Sure.
But for Boscovich, all the points are identical.
I think I'm getting confused now. So Lederman,
Lederman made it.
he makes a mistake.
Yes.
So is it quark? You think quarks are made from point particles?
According as I know, but this is not my field, but as I know, quark has different properties.
Yeah.
There are different quarks having different properties, but it is still stated that quarks are the most fundamental particles having no parts.
That we know so far that they.
No parts.
Yeah.
But let's elaborate to this. They know, but there are different types of quarks, different qualities of quarks.
Yeah.
So, what are the quarks? I don't know. But let's go several steps in hierarchy matter.
Yeah.
Okay. What is difference between carbon, diamond and graphite? Both of them are composed of carbon.
Yeah.
But diamond is very solid, but graphite is very soft. Is it true?
Yeah.
But they are different. Why? Because there is difference in the structure. Is it true?
Yes.
Then, if you have, for example, I will not write a chemical formula, but what is different between water and sulfuric acid? Water is H2O, sulfuric acid is H2SO4. Why they are different? Because they are different in composition. They have different properties of water and the sulfuric acid or alcohol.
Yeah.
So the difference between some matter originated because they have different composition, or if the composition is the same, like in diamond and graphite,
Yeah.
then different structure. So different space arrangement. So different properties of some substances or particles due to these differences, structure or composition.
Yeah.
So that's we know.
Yeah.
For example, difference between hydrogen as a chemical element and iron
Yeah.
is because hydrogen has one proton and one electron, and iron has, don't know, many protons and many electrons and many neutrons. Different composition. Now go to the quarks.
Yeah.
Let's go down. Quarks have different properties. They have different properties. Why? Because they have different in composition, or there is difference in composition, or difference in structure. If the quarks have different composition or structure, those quarks have parts.
Mm-hmm.
They have parts. So we shall come further and what could be the parts of those quarks? Those parts that have no differences in properties. And those parts are points of Boscovich. And that's the Boscovich stated.
Mm-hmm.
He concluded that as you are going at a higher level in hierarchy of matter, it is more and more complex. But when you go back down, you will come to the elementary points without differences. All should be the same.
Mm-hmm.
So for me personally, it is not opinion of current science as I know. Those quarks must be complex particles, not simple.
I think mainstream physics is, when they've investigated into it, I don't think they can cut quarks down any further.
See, when you say they cannot cut, this is technical question.
Yeah.
The question is if they are elementary or complex.
Yeah.
Maybe never they can cut, but it is believed that they are elementary particles, no parts.
Yeah, but I think you're supposed to be going on empirical evidence, and if your empirical evidence is you can't cut them.
This is question.
Sorry?
This is a technical question for me.
Technical, yeah. But
Yeah, this question, maybe never.
I think it's a question of then two different ways of thinking about it again, because you've got people who think in terms of empirical, and so you're going to do an experiment and you're going to see whether you can do certain things, and say if you've got a particle and you're trying your experiments and you can't cut it any further, and then from the empirical evidence you can then conclude, based on what I can so far do, that particle cannot be cut. So that's one way of thinking. And another way of thinking would be, looking at it, I see structure, and so from theory I'm going to deduce that it is made of something smaller. So you've got two different ways of looking at it. So, and that causes conflict again in people's thinking processes.
I have no such conflict. I say very simple. I believe that the quarks are different because they have different composition or different structure. They are composed of the some smaller particles, but physically maybe cannot divide it.
Do you have sympathy for the other point of view? That's going to look at it and say, I'm looking at this particle, and best that I can do at the moment is I can't cut it, and that's from my empirical evidence, and so based on that I'm going to conclude that you can't cut it, but maybe further on down the line you may be able to overturn that with another experiment. Do you have sympathy for that point of view?
It is simple. Now I will elaborate my concept. Finally, not my Boscovich concept.
Yeah.
Finally, the most elementary particles are fundamental are points.
Yes.
No dimension, not possible to cut. Those points cannot be cut because there is no what to cut.
Exactly. It's kind of like the point by definition. A point by definition you can't cut.
There is nothing to be cut.
By definition.
Yes, but another issue of Boscovich and all the people dealing with the Boscovich theory spoke about these points. It is very difficult to imagine those points without dimension, indivisible, and so on. And because of them, because of this concept, they reject Boscovich theory, or not able to accept it, they reject. And together with each rejection, they reject this curve. Reject this curve. But Boscovich wrote, this curve is valid not only for those elementary points, but it is valid for any kind of particles at any level in the hierarchy of matter. So, for me, who cares about these points? Whether they exist or not, I don't care. Is this valid for my... Yes, I don't care about that. I ask myself, this curve should be valid for the atoms. Okay, I found it valid. It should be valid for molecules. I could find the evidence. Is it valid for my macromolecules where I'm dealing with them? It is valid, confirmed. Is it valid for nanoparticles? It is valid. I don't care about points of Boscovich. So I will not reject this curve. It is confirmed. But points, let's go philosopher to analyze, physicists, philosophers to think whether it is point-like or not point-like, and so on. Because we see what you say very frequently in modern science, includes philosophers and include scientists, of course, and they try to put philosophical aspects on limiting, how to say, achievements of science, on those limiting achievements of science where the science still is not sure what is happened there. In my approach to philosophy, I want to analyze the philosophical aspects of melting of water, of boiling of water, when you solute, put natrium, sodium chloride, that's salt, in water and it is dissolved. Philosophy of these normal aspects. Philosophy of condensation of water from the clouds and falling down. Because those phenomena are pretty well explained by modern sciences. And new philosophical principles should establish on those phenomena that are quite correctly, in most extent, correctly confirmed, explained, everything is known, you can make experiments. And when you establish these philosophical principles, then go and speak about black holes, Big Bang, about quarks, relativity. But we have no philosophy of everyday science. We have no philosophy. I want to see any philosophical analysis of, I told you, melting of ice. And that philosophy is given by Engels, Hegel, and that Greeks and all that philosophy. That's the story of attraction and repulsion.
So, based upon this philosophy that you're pointing out, you're leading to the force curve of Boscovich, but people have other philosophies. Do you appreciate people having other philosophies, or do you think you've got to look at things just by one philosophy, or can you have a sort of, well...
Yeah, I read a lot of things about philosophy.
Sorry?
I have read a lot of books about philosophy.
Yeah, so...
Not only philosophy, but also there is a book of Heisenberg, Niels Bohr,
Yeah.
Bohm, and see.
I want to try and get to point out, of all the philosophies out there, is there only one philosophy that is true, or can you look at things from different philosophies? What is your statement? Is there only one true philosophy, or can things be looked at by different philosophies?
That's philosophical question.
Yes, it's philosophical. Yeah, it's philosophical question.
Yes.
So,
nobody can prevent no one to think on his way.
yeah,
But and everyone has a right to choose how to think.
yeah,
But always should be, how to say, there will be some kind of critique, some kind of analyzing what is true, what is not true.
yeah,
I can imagine what I want, but what is it true? What are the empirical data? But not empirical data on Big Bang or black holes or quarks or relativity. What is empirical confirmation of this data on melting of ice?
yeah,
Melting of ice, or on dissolution of salt.
yeah,
Understand? On these simple things which is investigated very, very exactly. You have figures, data, everything. On the effect of pressure on melting of some substances. That's philosophy. To check. That point you should check.
yeah,
If you, otherwise you can put, and I didn't see that some of those other philosophers analyze the issues on such way. See, when I understand this story about attraction repulsion given by Edmund, by Engels and Hegel and later partly by Boscovich, in order to check if it is correct or not, I have read plenty of books from organic chemistry, inorganic chemistry, physical chemistry, physics, thermodynamics. I read about 70 books, and I analyzes it very carefully, compared all the statements, but on the level, on atoms, molecules, and more complex system in thermodynamics. So on those levels where modern science gave not final answer, but it is well known in most extent. And there I tested those philosophy opinion and further developed. And I wrote an essay about 70 pages. It was written by me in 1977. And from that time I just added new comments. Nothing was changed in the original text. Let's say, just added as a comments more evidences about that. And the second edition of this essay was made in 1993. And now I put it on ResearchGate. But it is in my language. What is meaning of pressure? What is meaning of temperature? What is meaning? Huh? And is there any philosophical analyze this meaning of pressure and temperature? Everyday term. Pressure. What is the collision of molecules and gases? Boscovich developed theory on collision of two bodies. Very simple things. Just how two bodies are collide. Very simple.
Trying to get to the thing. So, based upon this philosophy, we get this curve, and the curve is confirmed by experiments. Does that mean we accept that philosophy as being correct and reject all other philosophies, or do we have sympathy for other philosophies?
Always should be correct. In a great extent, Boscovich's philosophy is correct. Also in Boscovich's book, there are a lot of things that are not correct.
Yeah.
There are. Also in any other philosophy.
Yeah.
Maybe there's some concept that can be accepted. So there is no complete philosophy. There is no final truth.
Yeah. No final philosophy.
There is not possible. But to say, oh, this is now everything is clear. No. Boscovich's explanation of combustion. He used phlogiston theory. Wrong. But Priestley later used Boscovich. He was a follower of Boscovich theory. He discovered oxygen and explained what's happened.
Yeah.
So there are a lot of Boscovich's wrong thing.
Yeah.
So they say that Boscovich is everything is okay. As well as for the other scientists. See, for example, maybe, I think I found that in Hegel's philosophy. Very simple to finish that.
Yeah.
Very simple analysis. Hegel analyzed the general opinion of the physics in his time. That was beginning of 19th century. And what he writes, Newton law of the forces. He says, you, scientist, says that movement can be produced from nothing and can disappear. Movement can be only transferred from one kind to another.
Yeah.
Also, scientist says this movement cannot originate from nothing, but only from some other movement. That if some, and first Newton law, if some body is in rest, he will stay in rest. If it is moved, he will move at constant speed. But according to second Newton principle, the speed will be changed if there is some force to accelerate or decelerate it.
Yeah.
So this is statement of scientists that was analyzed by and then Hegel analyzed free fall. He said, this is a body. It is not moved. But there is attractive force between ground, earth, and this body.
Yeah.
This force can be expressed as some constant, but then mass of this body and mass of the earth, multiply it, and divide by distance r on the square, by the distance on the seconds on the square, r times r. And because of force is acting, this body will move. And will move faster and faster as a result of body.
Yeah.
So the movement is produced by acting of this force. But as the body approaches to the earth, force becomes higher and higher because the distance is decreased, and this is down. This mass, one mass, body mass earth divided by distance. Distance is decreased. So, in the same time, we have production of the movement and increasing of the force. Is the movement originates from the force, then force will be decreased and consumed and transformed in the movement. But you have at the same time the boat is increased. Something is wrong, gentlemen. That's conclusion of Hegel.
Yeah.
Is it true? And finally, when the body approaches to the earth, distance is zero. That means force is enormous high. And nobody will be able to take this body up. Because zero is enormous high. This is a logical consequence.
Yeah.
But it is not so.
Okay.
So that's that thinking of Hegel. I found this discussion in some of Hegel's book. I don't know exactly what in one of Hegel's book, but I have learned physics in primary school, in secondary school, at university. Nobody of my professors, or in no one of these textbooks I used to learn, nobody mentioned that there is something confusing. Nobody.
Yeah.
Nobody.
Yeah. It's
If it is infinite force because distance is zero,
they seem to try to miss out things which are confusing in science lessons, and they try to get to things which they can explain easily. Things that are complicated, they try to avoid, I think. Okay.
Okay, it's
Thank you.
it's 10 o'clock. I don't.